All right, so now that you guys have had a chance to look at this and get some of your thoughts down, you got to see a photo with the diameter of the record, which is 30 millimeters. So now I'm gonna walk you guys through the calculations so that you can kind of check your work and see what you came up with compared to the answer. So let's move this out of the way a bit. Actually, maybe a little bit more over here. So, all right. So today I'm gonna go ahead and write down the title of what we're doing. We are doing the area of a circle. All right. So we've got the area of a circle here. I'm gonna go ahead and zoom in. I will move my paper, don't worry. Hopefully you guys can see that a little bit better. So the formula for an area of a circle is, you can either, some of you maybe looked it up online or have a textbook that you were able to look in. The area of a circle is going to be A for area is equal to pi r as in the radius squared. So we found that for our record, I'm going to go ahead and draw a circle here for a picture. Not going to be a perfect circle, but that's okay. That's what labeling's for. So I'll draw here. I'm going to draw the midpoint here as well, so that I know what is halfway through, so that I can figure out my radius. So we were given the entire length across the circle for the diameter. So we know that our diameter is equal to 30 millimeters. So this whole thing right here, draw a little, is 30 millimeters. So in order to figure out the area of the entire circle, we don't need the diameter, we need the radius. And what we know is that the radius is the halfway point from the side to the middle point of the circle. So that must mean that if this whole thing is 30 millimeters, that the diameter is half of 30. And I know that half of 30 is 15. So I'm going to go ahead and fill out my equation with this new number of 15 millimeters for my radius. So I now know that the area of my circle is equal to pi, which I can write this up here as well. Pi is equal to 3.14. Now I'm just going to work with the first two numbers of pi. As you might know, there are many more numbers to pi that make it a bit more accurate. But if you guys are suffering from the same problem as I am at home, your calculator's dead. So I'm going to be doing all of my calculations by hand on paper, and it's going to be a lot easier to work with 2 digits going out to the hundredths place than it would be the entire decimal of pi. Plus 3.4 is a general approximation that we use for pi, so it'll work just fine. So we have area equals pi times r. We're going to put our radius, squared. So first we're going to do 15 times 15 because we're squaring it, right? And I like to do the area model. So I'm going to go ahead and scoot this up just a little bit. And I'm going to do 10 times 5 and 10 times 5. Doing the area model is my favorite way to check my work, especially when I don't have a working calculator like right now. So I'm going to do 10 times 10, it's 100, 10 times 5, 10, 20, 30, 40, 50. And then 10 times 5 again. And I've got 5 times 5, 25. So now I need to make sure that I add all of these values up. So I'll just do this on the side over here. 50, 25, 5, 10, 11, 12, 1, 2. So I've got 225. So bring that number back up here. Remember, this was 15 times 15. And I did just break it down into the tens and the ones. So 10 and 5 for both of those. So our area now is equal to pi times 225. And if we want, we can add our labels here, so that's going to be millimeters squared for our units. So now we technically have an answer with 225 pi, but that's not going to give us the answer, quite an exact answer. So we can be a little bit more exact there and use 3.14 to multiply these two together so that we can get our final answer. So again, I am, let's see, going to use more area models just because, again, that's what works best for me. So for this one, I'm going to go ahead and put it over here. So I'll move this up a little bit more. I'm going to do 200 for here, and then we've got 20 for the tens place. So I'll put my 20. And then I've got the 5. Put the 5 down here. And then for 3.14 for our pi, we've got 3 in the ones place, and then we've got the decimal point, so that's going to be 0.14. And that's going to be what I'll use for my area model. And I will draw my lines and calculate. So 200 times 3, I'm going to go 200, 400, 600. 20 times 3 is 20, 40, 60. 5 times 3 is 5, 10, 15. And then 200 times 0.14. This one might be a little bit tricky to do in your head, so what I did is I did write this one out. 0.14. So we've got the 4 times 0, we've got 0. 4 times 0 again is 0. And then we're going to keep our decimal in the same place. So we're still going to have 2 numbers to the right of the decimal there. So I'm going to go ahead and put my decimal there. Do 4 times 2, 8. And then I'm going to add a 0 because we're shifting one more place value to the left. So we need to make sure that our first value is in that same place value. So 1 times 0, 0. Again, keeping the decimal in the same spot. 1 times 0, 0. 1 times 2 is 2. So now I need to add these two values, and I'll get 28. All right. And then I can do the same thing for here, but I also know that 20 is just one decimal place off from 200. So I know that this is going to be 2.8. And then for the 5, I'll go ahead and do that one over here as well. So I've got 5 times 0.14. So 4 times 5 is 20. Write that down. Put my decimal. Then I'll add my 0 to maintain the same place value. Do 1 times 5 is 5. And a 0. Or decimal, my bad. Make sure I add these. Oh, I have to put plus sign over there. And then I've got 0.70. So now, just like before on this area model, I'm going to add all of my values there. Oop, and I'm just going to add these ones and these ones separately and then add those two together, because that is the way that my brain works. You might do it a little bit differently, and that's okay. I'm just showing you guys the method that works best for me. There are many ways you could do this. Some of you might feel more comfortable just doing a model like this. Some of you might be good doing it in your head. Some of you might have access to a calculator at home, unlike myself. All right, so we've got 0, 15, 8, 9, 10, 11, 2, and 3. So now I'll add these two values together to get, let's see, 6, 7, Sometimes it might help to add the zeros in the end too, just to kind of be a placeholder for you. 6, 7, 8, 9, 10. All right, so I got 706.50. So it looks like my final answer for the area of my Abbey Road Beetles record is going to be 706.50 millimeters squared, because we're still going to carry those units. All right, so I'm going to zoom out just a little bit and try to get the whole page on here. That way, if you guys want to pause the video maybe and just take a look at the methods, maybe the formula, just to kind of take note of that and see how you did compared to this. And feel free to try this out. You can do it with any object in your house. If you've got something to measure with, you can go ahead and take even, you know, a cup. I've got a little jar full of candy here. You could do it with stuff like that around your house. And feel free to see if you can come up with some of your own problems to share with your family.